Hello, welcome to Kotlin DataFrame demo. My name is Anatoly Nikitin and I am a lead developer of this library. In this video, I will tell you about key features of Kotlin DataFrame and show basic DataFrame operations. So, Kotlin DataFrame is a new Kotlin library for in-memory processing of structured data. And DataFrame is a key entity of this library that represents a table. That is basically just a list of named columns that contain data. Kotlin DataFrame has two main features. First, it provides type-safe access to data, so you can access columns and values of your data frame as properties using dot notation, just as you work with any other Kotlin objects. And this enables code completion, compiler time checks, so you can get compiler errors as soon as you type your code. And it provides a nice, simple, and very powerful type-safe API for DataFrame operations. Second, Kotlin DataFrame supports not only plain table structures, such as CSV files, but it also supports hierarchical data structures. So, for example, you can read any JSON file into DataFrame, preserving its original tree structure. And also you can import any tree of Kotlin JVM objects into DataFrame and inspect them using DataFrame API. So now let's explore DataFrame API using well-known dataset with Titanic passengers. I will show you how to use DataFrame in JuPyter notebook, and you will need Kotlin kernel for JuPyter. You can find it on GitHub, Kotlin JuPyter, and get installation instructions for that. And once you have it installed, we will create a new Kotlin notebook and use DataFrame library. This instruction downloads Maven artifacts for DataFrame library and integrates it with JuPyter kernel. After that, we can read the dataset using DataFrame read operation. Currently, DataFrame supports comma-separated formats and JSON formats. So we can read CSV and select Titanic CSV. And here we are. This is DataFrame with passengers. Actually, we can call read operation without specifying CSV, and in this way, DataFrame will detect the format of dataset automatically and choose the correct reader for it. So let's read DataFrame again and save it into df variable. So we can see that DataFrame has 1309 rows and 14 columns. And let's explore this dataset. We can select particular row of this dataset using indexing operator. For example, we can select the fifth row. Rows are indexed from 0, just as typical Kotlin arrays or lists. So here we have data row with index 5. And we can select also a range of rows from 5 to 10, for example, and get a data frame with 6 rows. We can get top 5 rows using head operation, or last 5 rows using tail operation. If we want to select a particular number of top rows, we can use take operation that is similar to Kotlin collections. Take 10 rows. So these are basic ways to select particular rows from DataFrame. We can also select columns from data frame. How can we do this? The most obvious way is to use column names, and we can select, for example, column with name and get it as a data column object. And then we can select a particular value from this column. For example, we can select the first value, and but here we get the problem. If you want to, for example, to call substring on this string, we can't do this because when we select column using string API, we don't know the type of this column, so it should be casted to type string in order to use this operation. And this is the major problem with using data sets in statically typed language such as Kotlin. So how can it be solved? We can remove this string indexing and just select data column name from this data set as if it is a typical property of data frame object. Looks like magic, isn't it? And then we can select the first value, and it will be of type string, so we can call substring without any additional type casting. We can also select the first row at first, and then select name, and it will be not a column but just a string value. So we can also call substring on it and get the same result. So this is the major trick that allows to work with data in Kotlin in a simple and straightforward way. But how it works? Let's get a little bit into internals. We will add track execution magic keyword that will show us all silent executions that are not visible in Jupyter, but they happen between code cell executions. So let's see how it works internally. We restarted kernel to see everything from the very beginning, and now we read DataFrame, and we can see that after reading DataFrame from the file, additional code cell is being executed, and it generates empty interface DataFrame type, and it generates a lot of extension properties. And these extension properties are generated for every column of DataFrame. And for every column, two properties are generated. One property for columns container of this type. For example, for column age, we have column container DataFrame type .age. It's an extension property that returns data column of type nullable double. And the second property is generated for data row with the same type argument DataFrame type, and it returns nullable double value. So this is the major trick that is used, and these extension properties are generated for all columns, and at the end we can see that the original data frame is casted to this empty interface type, so that all these extension properties become available for data frame object. And it's important to mention here that internals of data frame are not changed, and the object itself, the instance of data frame object, is not changed. It's just casted to another type argument, and all extension properties become available for it. So after execution of this cell, we generated properties and replaced local variable df with casted variant of data frame, that enables these extension properties. But now let's explore the data frame that we just loaded. Let's check the schema of data frame. After reading it from CSV file, data frame automatically detected int and double columns from it. So we can see that all columns in this data frame are either contain ints, strings, or doubles, and some of them are nullable and some are not. That's also important because empty values from dataset were converted into null values, Kotlin null values. So some columns provide nullable values and some columns provide not nullable values. And for example, we can get column age, and it has property. It has function has nulls that returns true because this column has nulls. So nullability tracking is performed at runtime depending on actual presence of null values in particular column. As soon as age is nullable column, we can't, for example, add 1 to this nullable int. Now let's take top 10 elements from this dataset and check its schema again. So we can see that first 10 elements doesn't contain null in their column age, and that's why schema of this sliced data frame has age of type double, not nullable double. So if we assign this sliced data frame to variable top, for example, we can see that a new interface type was generated, data frame type 1, and several that extends original type, data frame type, and it overrides several extension properties for it. So the sliced data frame was analyzed. We inferred the schema and found that age doesn't contain nulls anymore, and so data frame generated new extension properties for column age that now has type double, not nullable double. So in the next cell, age doesn't have null, and so we can select first value and, for example, add 1 without compiler error because now it's just int. So this is the major approach to nullability in Kotlin DataFrame. We infer schema, detect whether a particular column contains nulls, and generate nullable or not nullable properties for it. Let's explore some other basic operations with data frame. We can get basic info about the dataset using columns count operation that returns number of columns, or rows count that returns number of rows. Before we continue, let's turn off execution tracking. Okay, so we can get column names as a list of strings. We can get column types as a list of Kotlin type, and we can get extended info about columns in data frame using describe operation. It returns data frame that describes every column in data frame, name of the column, type of the column, number of values, number of unique values, number of nulls, top value that is the most frequent in this column, frequency of this top value, so how many times this top value is present in dataset, mean value of column, standard deviation, mean, median, and max. So these are basic statistics that you can get to understand what data you have in your dataset and get some basic overview. So we saw how we can select one row or several rows and how we can select one column. So now let's see how we can select several columns from DataFrame. We can do this using select operations that is similar to SQL select. It has lambda argument that allows to select columns that we want to be present in the resulting data frame. Now let's select, for example, survived and name and age columns. So you can see that API is very straightforward. We just type the names of the columns combined with end infix function and get data frame with these three columns as a result. And this lambda that is used for selecting columns provide a very powerful DSL for selecting any sets of columns from DataFrame. And that's important because these column selectors are used in many DataFrame operations that you will see further. We can select several columns from DataFrame and rename some columns to a new name, similar to as operator in SQL. In DataFrame API, we used named infix function for that. So we can select survived column and rename it into, for example, alive, and select other two columns without change. So now we have these three columns and the first column is renamed. We can also select a range of columns. For example, we can select all columns from survived until age, and we get 4 columns. Or we can select several columns using their index. We can select, for example, columns 3, 5, and 6, and get 3 columns, or select a range of columns from 3 until 6. We can also select columns using different conditions. For example, we can select all columns that starts with B. So we select all columns that have a name that starts with character B. Or we can select all columns by column type. For example, we can select all columns of type string using calls of selector and get 2 columns. And this selector distinguishes between nullable and not nullable columns. So if you want to get also columns that contain nulls, we need to select calls of string nullable. There are even more complex column selectors that can be used here. We can select columns by any arbitrary condition using calls selector and passing condition that we will use to select column. For example, we can select all columns that have nulls. And all column selectors can be combined in different ways. One of the ways to combine is to use AND infix operator, and another operation for combination of column sets is except. So we can select all columns that have nulls except column H, or except age and both, or except age and calls of string nullable. So you see, any complex expression can be used here to select particular sets of columns. And select operation returns a new data frame. So it's important that all data frame operations, they return a new instance of data frame. So data frame object itself is immutable, and when we return a new instance after operation, underlying data structures are reused as much as possible, relying on this immutability of original data frame. Now let's explore basic statistic operations with DataFrame. For For example, let's find maximum value in the column H. We call def max and select the column H. Here we are. If you want to compute maximum value for more than one column, for example for age and fair, we can select two columns, but we should be ready that this syntax will return maximum value across both two columns, age and fair. So if you want to compute separate max for age and separate max for fair, we should call max4. And here we'll get data row with the two columns, age and fair, with maximum values for it. Similarly, we can call not only max, but for example min 4 and get average value for these two columns. And there is a let's look at the operation count. Count without arguments return the same value as rows count, but we can pass a predicate to count only rows that satisfy this predicate. For example, count where age is not null, and get number of rows satisfying this condition. Let's stop here for a while and check the arguments for this lambda that we pass here. You can see that call to age property doesn't include it keyword that is often used in Kotlin lambdas. Actually, we can use it and, for example, get completion and to select particular column, and we have an option whether we will use it or not. So this and it objects inside all DataFrame lambdas refer to the same data row object. So we can use it or we can skip it and get the same results. Let's take a look at some other operations. Let's not only count the number of rows with age not null, but filter them. So filter the rows where age is not null. We get the same 1046 rows and return a new data frame with a subset of rows. It's important to repeat here again that data frame is immutable, so original data frame doesn't change. We can also use a reverse operation for filtering. It's called drop age not null. So it will remove all rows that satisfy this condition. So we'll get only rows where age is null. What else? We can use sortBy, similar to Kotlin collections, to sort rows by some columns. And for example, we can pass here name, sort by name, and get rows sorted by name. Or we can pass several columns for sorting, for example p class and name. So first it will be sorted by p class and then by name. And we can specify the direction for sorting for every column. For example, we can sort p class in descending order using desc modifier, and name will be sorted by default as ascending order. One more thing here, if we sort some nullable column, for example sort by age, by default we will get null values on the top. So if you want them to be at the end, we can pass nulls last, call nulls last modifier at particular column and get column sorted by age, get the data frame sorted by age, and nulls will be in the end of data frame. Next operation is update. Let's take a look at how we can update values in data frame. So actually it will not modify the original data frame, so it will return a new data frame with updated values in some columns. Let's update all values in column name with uppercase. To do this, we call update and select columns for updating, and this operation returns some intermediate object update clause that can be used to configure further the update operation. So we call update name with it uppercase. So update operation is consists from several calls that configure this operation, and the most straightforward API is to update column with expression. We can also use inside with, we can use other columns as well. For example, update name with home desk. Just copy the values from one column to another, and so on. Or pass some expression, for example, name plus brackets plus age plus brackets. You can replace username or just its current value to the same result. Name and edit age. And we can add a condition for updates. So update, in this case, we will update not all the columns, but particular columns. We can add where clause, and for example, select all columns where sex is male, for example. Okay, so we added age only to columns where sex is male, and or we can specify particular row indices for update. For example, update 4, 6, 7 row with expression. Here we are. Now let's try to update survived column, and now you can see that it has type int. And what if we want to convert it into a boolean that will have true values for 1 and false values for 0? You may think that we can use the same update operation for this and call update survived with it equals 1. But here we'll get compile time error. If we hover it, we can see their message that inferred type is boolean, but nullable int is expected. So this is because update operation doesn't allow to change column type. This is important because this can be used to prevent accidental type changes when you didn't want to do this, but pass some expression that changes the type of the column. In some cases, it may be unexpected. So if we actually want to change the type of the column, we should use not update operation, but convert. Convert has similar syntax to update, but it allows to change the column, but it doesn't allow to select particular rows. So convert will always be applied to all values in the column. So convert survived with the expression, and now survived is column of type boolean, and it has true and false values. More operations. Let's try to add a new column to DataFrame. For example, let's extract the part before comma in name and add column last name that will contain this part until comma. So we will call add. This is for adding columns, and pass the name of the column, last name, and then we pass an expression for the values in new column. Here we have also row context, so we can use it. It will be data row, or we can just use any row values. So we'll take value from column name, and it will have type string, and we call substring before comma. Here we are. A new column was added with the name last name, and it has the parts of string from name column. Similarly, we can remove columns. Let's remove column name. Just call remove and select column name for removing. As I said before, we can use any column selectors here, so we can remove all columns of type string, for example. That's very simple. We can also not only add and remove columns, but we can move columns from one place to another in DataFrame. To do this, we will use move operations. So we select column for moving. For example, we will move column H, and there are different ways to continue this operation. The most simple is just to move column into particular position. For example, you can move column to column position 2, 0, 1, 2, ages position 2, or we can move column after some column, move after survived, and we can move even several columns after some column. It's just same way age and fair after survived. Okay, then we can also rename columns. So let's rename column survived, for example. I showed you before one of the ways to rename columns during selection. So we can select columns and give it a new name, but we can also just rename particular column survived into alive. Here we are, column is renamed. What's more, we can group columns. We can take several columns. For example, let's take columns from CBSP till body, all these strange columns, and we can put it into column group. So let's see how it will work. And group CBSP until body, and group it into group. We'll call it details. So this is the first way to get column group in your data frame. So now we see that we have a special column details that contains other columns, CBSP, parse, ticket, fair, cabin, and so on. And we can expand and collapse it. Let's save this grouped data frame into a variable grouped and see how we can work with it and print it. So let's take a look at details column in that we just created. It is a column group inside data frame grouped, and we can use extension properties to navigate inside this column group as well. So we can take, for example, CBSP data column from it. So just like we navigate through Kotlin objects, we can navigate through a column hierarchy. And if we just take a look at grouped details, we can see that it's a column group and it looks like a normal data frame. So actually it is a part of original data frame that was kind of extracted from it, and so we can narrow our scope into this column group. Actually it is a data frame, so column group implements data frame interface, so all operations that are available for data frame, they are also available for column groups. For example, we can select columns from this column group and get these two columns, or just call any other operations. if we get particular column, we can select value from this column by index, and here we can mention that we can move this row indexing across our expression, so we can use it at the end and select columns first, and then we select row number, or we can pass it here. So first we select column, then we select a row, and then we select value from this row, or we can pass it to the front and we'll get the same result. So it doesn't matter in what order we select columns and rows, we'll have the same API and we'll get the same result. So let's return to this groups data frame and remove this column grouping that we just created. Reverse operation for column grouping is called ungroup. So we call ungroup and select columns for grouping, ungroup details, and so here we get a original data frame without groupings. And there is also a special operation that removes all the groupings from data frame. It's called flatten. So if we have a lot of deeply nested columns in our data frame, we can call flatten and get it plain. The only thing that you should care about here is that data frame requires that all column names must be unique and not empty. So if you have some equal names in some deeply nested columns, flatten may fail because of this naming conflict. Let's return to our original data frame. We'll explore one more important operation that is often used: split. The split operation allows to split values in particular column into separate values. Let's split column name using comma as separator. So we select column for splitting, and if you call it, we have some strange results. We have split object, and you can see that this column is named now split1. So we can specify their delimiter for splitting. So let's split by comma, and now we will get these two columns, first column and second column, named split1 and split2, and we can specify a name for this. So current result is also an intermediate object split, and now if we specify names for the splitted columns, this will be last name and, for example, first name. So we'll have this column split into two and with the valid names. Let's also use dot as separator, because it's also used here, and we can pass the second separator for splitting. Now this column is split into 4 columns, and first 2 columns give names first name, last name, and first name. Other 2 columns are named split1, split2. So let's add more column names. First name, and what is the last column? I don't know, it contains null. Let's just call it question mark. Last name, middle name, first name, and some other parts we need to investigate it further to find out what's there actually. So this is the most simple way to split columns. We can also split this column preserving original column name, so that resulting columns will be placed into original column, and original column will be converted into a column group. So let's do this. We replace into with inward operation. Inward means putting the columns inside. So now we have this column name that was originally present and 4 columns inside this column: last name, middle name, first name, and something strange. Another way to split is to split values not into new columns, but into a list of values that will be stored in the original column. This kind of splitting is called in place. So we split the column and store the results inside original column name as a list of string. So let's save this data frame with the column name splitted into a list of strings. Name is splitted. Let's take a look at explode operation. Explode means spreading a list of values from some column into new rows. So we can duplicate every row and use values from a list of string as values for name column. Let's take a look how it works. Split it, explode, name. So you can see that these rows were duplicated and we've got all their name parts present as separate rows in this exploded data frame. Reverse operation for explode is called implode. So if we explode and then implode, we'll get the original result. So implode merges several rows back into one row by combining values into lists. So these rows are grouped by all other columns. In this case, it's all columns except name, and name column is converted into list. So explode splits rows vertically and implode merges them back into lists. Actually, we can combine this explode operation with splitting. So if we call split not in place as we did before, but into rows, it will be the same result as split in place and then explode. So this is one more terminal operation for splitting: split into rows. So we split the column and create new rows for this, similar to explode. Next operation, groupBy. It's used very often if you need to group rows by unique values in some columns. So let's group by our data frame by cabin. And here we get a third kind of column in data frame. It's called frame column. It's named group, and it contains data frames. So we have data frame with column cabin, it's a key for grouping, and column group that contains data frames with the rows from original data frame. And we can expand these data frames and see these original rows present in it. And it's also an intermediate object in groupBy, so it's not a data frame yet, although it's rendered as data frame. And we can, to convert it into actual data frame, we should finish this groupBy operation with some terminal operation. Let's, for example, use count. This will count number of rows in every group, and so we get to columns cabin and count. Or we can compute some other statistics, for example, maximum age in every cabin, or maximum age and fair. And so we use the same API here as we used for ordinary data frame aggregation, max for age and fair. So we groupBy and compute statistics. GroupBy provides also a general way to perform aggregations on data groups. It's called aggregate. GroupBy, and in aggregate we have a context of particular data group presented as data frame. So each and these objects refer to data group, and we can perform several aggregations here. So we can compute count on this data group and store it into column count using infix function. And we can also do some other aggregations. For example, we can take age max into max age. So compute maximum age for every group. Oops, here we get an exception because some groups doesn't have any not null values in column H, so we should use max or null here to fix this exception. To simplify this expression, let's drop all rows with null values in H. We can use it. We can do this using df drop nulls operation, drop nulls in H. Okay, so we have 1046 rows without nulls in H column. Let's save it as with H object, and now use it in our groupBy operation. So we can use max now without max or null, because age is not nullable anymore. Let's add one more aggregation for grouping. Let's select the oldest person from every cabin. We can do this using max by age. This will return a data row representing a person with maximum age in current group. And let's put it into column oldest. So you can see that a new column group oldest is created, and we have all rows from original. We have all columns from original data frame into this column group. If you don't need all the columns, we can select only particular column value from data row representing person. For example, let's add only name of the oldest person into column oldest. Here, cabin count, max age, and name of the oldest person in the cabin. And the last operation that we will explore in this demo is pivot. Pivoting is a kind of complementary to groupBy. So groupBy groups rows vertically, and pivot groups data horizontally. So it creates new columns based on values from a particular key column. Let's do this. Turn to our data frame, and let's pivot column P class, for example. So this will take all distinct values from P class column and create new columns from these values. So here we are. We have 3 columns, 1, 2, 3, and we have data frames with data groups for every value of P class. And this is just a single data row. We have intermediate object pivot here, so we need to continue pivot configuration. So we can convert this pivot into matrix, so it will be grouped both by columns and by rows, horizontally and vertically. So to do this, we add grouping. So pivot by p class and group by, for example, by embarked it's a city where person was embarked into Titanic. So if you do this, you can see that we have p class with 3 columns inside, and we have column embarked with its values similar to original group by. So here it's a matrix, and the values of this matrix are data frames that we can expand and explore. And we can compute any statistics here as well. For example, we can compute count, and so we'll get number of person per p class and per embarked value in this matrix. The pivot and group by, they work together, and actually you can swap these operations without changing the result. So we can call group by first and then pivot. It will also work and we'll get the same result. So it doesn't matter whether we group horizontally or vertically first. We can do this in any order and get the same result. We can use any statistics here, for example, max age as we did before, and get some null values and ages here. And this is already a data frame, so pivot is configured and we get the result. Let's swap it back. Nothing changes. And also we can use full DSL for aggregation here. We can call aggregate and put count into count and max by age name into oldest. So here we are. For every value, for every combination of embarked and p class, we get 2 columns, count and oldest, with 2 values. We can collapse them and see it's similar to original data frame, but with not just one value, but data row that was put into column group. So now these columns are not value columns but column groups, and we can expand them. So these are the basics of data frame. Every operation has quite advanced API, and you can explore this API. I just showed you with the very simple cases. There is much more in API available for data transformations. So go to DataFrame GitHub. And explore the documentation. It describes domain-specific language DSL for all data frame operations. For example, if we go to update, we can see this pseudo code that describes all possible combinations of calls that are available for update operations, and we have different samples here. So go ahead and try it on your examples and give us feedback on how you use it in your cases and what problems you face, if you have any. So feel free to report any issues to DataFrame GitHub, and contact me directly if you need any assistance as well. Thank you for watching. Bye.